Hi everyone, I'm Ziheng, and I'm here to present my project for the 15821 course, which is Cloudlet-based real-time deep face swap on mobile devices. Okay, I know, that's a very long name you see there, and you probably wonder what is face swap. So probably you will have this kind of dreams in your childhood that the guy speaking in the TV is not Mr. President but you. And now with this kind of application, your dream can actually come true at least partly, because what we are doing here is we are trying to model your face into a celebrity's face. So basically what it does is you open your phone, you open the app, and you give yourself a self-portrait video stream, and the video stream is going to transfer your face to a celebrity's. So this project is based on the idea of GAN, which is in full name Generative Adversarial Networks. GAN is a kind of deep learning model that tries to generate two models at the same time. Its aim is to do the task of machine translation, image translation. For example, as you can see here, probably it's a little bit small, but you may just want an application that takes in satellite video or satellite image and transfer that to a map, to a landscape of a map. And that's the kind of thing GAN is good at. So what it's trying to do is trying to utilize input source and the target, with the target being the kind of image that you want the transformation target to be. And the source and the target is going to be trained together to construct a generator and a discriminator. So the use of the generator is trying to generate fake images that's very close to the target translated images. And the discriminator is it's trying to discriminate the fake generated images from real inputs of source images. So in this way, these two kind of models can evolve together and get better results. And after some epochs, it can actually train this kind of satellite input image to a very well organized map. So that's a method we're trying to use in our project. And here is what we have actually done. So first, we're going to use celebrities' video as training input data, and we're going to generate the source to be the celebrities' facial landmarks. So the first step is we take a video, we get all the frames from it with the person's face in it, and we're going to generate landmarks as the facial expressions, like the features of that guy's face, into this kind of landmark picture. And then we're going to use this picture as input and this picture as a target to train a machine learning model, which is essentially the GAN model. So after we train this model, we now have a generator that can transform this kind of facial landmark images to a celebrity's face. So now we have our own video stream, it's taken from the front camera of our smartphones. And this kind of facial image is going to be mapped to the facial landmark. The last step is we put this facial landmark into our model that we just trained, and the model is going to turn the facial landmark into the reenacted person's face with the facial expressions that we have. So why is this related to mobile and pervasive computing? It's because this whole project cannot be done on a cell phone alone. We all know that the processing powers are growing in our cell phones, but this one, it even have very low frame rate on a well-equipped Cloudlet server. On the server, which have 8-core CPU and Tesla GPU, these models running under only 12 FPS. And we try to build portable TensorFlow model and try to load it in our cell phone, and we cannot just open it. So this is a perfect kind of application that is that can be run on Cloudlet, and we can utilize the low latency and high throughput feature of the Cloudlet make this kind of thing smooth on our cell phones. So that's why I do this kind of system design, which consists of the mobile device, the front end, and the Cloudlet server. So basically, the workflow here is we're going to take video stream from our cell phone's front camera, and we're going to we're going to transport that video stream to the backend Cloudlet server for it to process. The backend process server is going to feed the input in the model we just trained, which is a face-to-face model, and the model will reenact our face with celebrities and return that stream to the display of the front-end video device. So we also have introduced a feature that the fidelity of the output video, for example, the frame rate and also the resolution of the output video can be dynamically adjusted based on our detected network conditions. For example, if you are in a world where the network connection to the Cloudlet is not perfect, it's very slow, and which is going to make the latency of the image processing very huge, we are going to reduce the fidelity of the return video so that it can actually run smoothly on our cell phone. So we have learned a lot from the training and development from the training of these models and the development of this application. The first thing we get is that the quality of trained data is very important because we trained over 20 models, and only 5 or 6 of them actually works and actually can do proper facial reenactment. The second one is we must pre-process the data before we can do this kind of image transformation task. The kind of pre-process we do here is for example, when you are holding a camera to your face is either going to be too close to the camera so that the image is probably too huge and not properly reenacted into the target, or it's maybe too high or too low. So the reenacted person's face may be below his neck, which is kind of creepy. But what we do is we do a landmark space transformation, which just transform our face landmarks here, like a very big one, to actually the dimensions of the input source videos model. So for example, as we can see here, we're doing this, we transform my big face to this one that is similar to the size and position of Angela Merkel's face here. So we can get the proper result with facial reenactment. The last thing and very important thing here is the latency is very, very important in this kind of app because it's a live video transform and translate task. You don't want the video to lag 5 seconds before you can see your facial expression accurately reenacted to someone else's face. So by using Cloudlets and well-established high-speed network, we can achieve really good latency with facial expression transfer. And that's the thing we learned here. So thank you, and that's all of my presentation on this course project, facial reenactment on mobile devices. Thanks.